Hey guys, so we have seen these particular molecules everywhere. So you can find it in your clothes, in your closets, outside in our environment, in all the living organisms, trees, and yes, all of them are made of carbon and hydrogen bonds. So, first of all, we are going to figure out the properties of carbon and hydrogen. We all know that carbon here, it has 4 valence electrons, which means that it can bond into 4 other elements. And that hydrogen here has 1 valence electrons. So this can bond into some other elements. Just one of them. And yes, so most of the organic molecules that you can find everywhere contains solely carbon and a hydrogen, while some of them may contain oxygen, fluorine, nitrogen, bromine, some other halogens. But most likely, you're gonna be finding carbon and hydrogens. And we've also come up with this term called saturation and unsaturation. Now, saturation is a molecule that consists of only a single bond. Meaning that if you found a particular molecule that has a double or a triple bond, they can be classified as unsaturated. Now, first of all, welcome to organic chemistry, where I'm going to tackle we're going to introduce ourselves to every molecule. And these 3 are, I think, the basics upon all. The first is called alkanes. Now, alkanes are actually the ones that only contain a single bond. So they only, sorry for the terrible writing, they only contain a single bond. Now, this is actually one of the most popular ones, and we are using this to combust any materials. I mean, think about it for a second. If you're doing a barbecue, right? All of the fuels that are from the barbecue are called propane. Now, propane contains of 3 carbon with some amount of hydrogens. So this is the molecule looks like. And it has 3 carbons and 8 hydrogens. Now, some other ones where most of you guys are using in your cars, only if you have the regular cars, not the hybrid or electric ones. These are called octane. And it has 8 carbons and 18 hydrogens. So it kind of looks like this. Three, 4, 5, 6. Now, this has 8 carbons and 18 hydrogens, and it is called octane. Now, for some of you guys, you might think, well, there might be an occurring pattern in these particular situations. And yet, yes, indeed there is one. So, we have to familiarize ourselves with some prefixes. And this is how you name, or this is the organic nomenclature of an alkane. So we have to introduce that ourselves. So if there's only one carbon in the molecule, we call this met. The second one is called et. So one carbon. And this one is two carbon. Oops, my bad. I meant to say B instead of T, sorry. Carbon. This one called pro, which I just introduced you guys earlier. Pro, which means it has 3 carbon. And we've got here bute. I'm tired of writing carbon, sorry. Pent, which is 5, sorry. And we've got hex, hep, and so on. So for all of this, other than bute, these are actually, you guys can figure it out already if you have learned geometry in elementary school. You know, the octagon, hexagon, heptagon, nonagon, and dedagon. Well, all the prefixes from those can be actually used in this theory. So if you guys know all those, that's great. That's awesome. Which means that you only have to know met, et, prot, bute. Now, let's look at some of the most common examples of how, in terms of how we write or draw our molecules. This one is called a structural formula. Now, a structural formula contains of a separate bonds of carbon and hydrogen. So you can actually see implicitly, more specifically, what's going on in terms of how carbon and hydrogens are interacting with each other. Now here we have a condensed structural formula where we just kind of compress the carbon and hydrogen bonds, making it a CH3, CH2, and CH3. So these are all, by the way, these are all propane here. We're just looking up the different representations on how we draw this molecular formula for propane. This one right here we call an empirical formula. Now this is highly compact and condensed, so we can't really see what's going on in here or what the overall structure would look like. But it can pretty much tells us as to how many carbons are in there and how many hydrogens are in there. Next one, we have a line diagrams. Now this is actually one of the most simplest ones, especially when you're drawing some of those complex molecules. This edge here, or this corners here, by the way, there's a carbon for each of them. So I can tell that for both ends of this one here, they have CH3, and this other one is called CH3. So for example, if you have this here, we can call this, actually sorry, this is butane, by the way. This is butane, my bad, because there's 4 carbons here. There's 1, 2, 3, 4, and right here is propane. Now here we have 3 types of hydrocarbons. This one here is an alkane, and it is a saturated compound. On the other hand, alkenes and alkynes are both unsaturated. And because of the nature of the double and triple bonds. So all the prefixes that we just introduced earlier, the met, et, prot, but, pent, are actually can be used in all these different types of hydrocarbons. The difference is though in the suffix. For anes, it ends with ane. So this is for the suffix of it. On the other hand, for the alkenes, we call them ene, and for alkynes, we call them ine. So ane, ene, ein. Now we have this particular example here. To name this organic molecule, we have to find the longest chain of carbon bonds. In this case here, these are the longest chain. And so to name this side chain here, we have to number it the ones the closest end of carbon chain, which means that we start from here. If we start from here, 2, 3, 4, we can actually name that appropriately. Now, and by the way, this is called haloalkyl. Sorry, not haloalkyl. That's for halogens. They're just side chain. By the way, sorry about that. Haloalkyls are actually the ones with the halogens, which I will talk about later. This one here is called methyl group. Oh, by the way, it's called alkyl. My bad. Just alkyl. This here, or all the side chain bonds of CH carbon and hydrogens, they're called alkyl. I will talk about the haloalkyl later on. But this one here is called methyl. So first, we have to address specifically as to where this methyl group belongs to. In this case here, this methyl group belongs to carbon number 2, which means that we put 2 methyl. And by the way, there's 4 carbons in here. 1, 2, 3, 4. So we have 2 methyl butane. So for these particular elements, bromine, fluorine, nitrogen, chlorine, and iodine, in terms of putting this in some chemical compounds, we actually change the suffix of all of this. So all of this are changed. So this can be replaced by mo. So for example, if we have CH3, CH, and CH3, and we have Br. So again, we have to find the longest chain, which is right here, and then we're gonna name it accordingly. 1, 2, 3. So it's gonna be 2, and instead of putting bromine, we are putting bromo. Propane, because there's 3 carbons in there. So it's called 2-bromopropane. Let's put our example here. Alright, so for this example, we are gonna name this particular chemical compounds. First off, we have to find the longest chain of carbon-carbon bonds. In this case here, we have this one right here. Secondly, we have to name or number our carbon bonds. So I think this is one right here. I'm gonna change different color, sorry. I use blue. So in this case here, we have to number from 1, 2, 3, 4, 5. Great. We have 5 carbon, which means that we have pentane. Third, we are going to name the side chain. And by the way, how you name this side chain is that you have to start with the alphabetically. In this case here, since we have a iodo, and right here is an ethyl, I think ethyl goes first before iodo, because A comes first than I. So we have 3 ethyl, 2 iodo, pentane. Okay, so let's go for alkene. In this case here, we have 1 double bond. I'm gonna use green one this time. This one here is a double bond, and we got our fluorine. So first off, we have to figure out where is our longest chain. In this case, we have right here, and we have 1, 2, 3, 4. So 1. In that case, I'm gonna use sky blue this time. Since there's 4 bonds of carbon, we can call them but. And note that since we have a double bond right here, we can call this 2-fluoro, and also we have to name specifically where the double bond is. In this case, the double bond is located in carbon number 2. So we have but 2-ene. Alright, so let's consider this example here. Now, we have 2 double bonds, and we have a side chain of 1 methyl groups and 1 bromo or bromine. To name this molecular compound, let's start off with figuring out where is the longest chain, or which one here is the longest chain. In this case, we have this entire length here is our longest chain of carbon bonds, and we can start numbering from here. 1, 2, 3, 4, and then for that we're gonna start writing out the side chain that has the least alphabetical order. So for instance, if bromo here starts with B and it comes first, then methyl. In this case, we have 3 bromo, 4 methyl. And since we have 6 carbon-carbon bonds, we're gonna name them hexane. Sorry, my bad. Hex. Also, note that there is 2 double bonds here, so we can do 2 and 3, and it's gonna be hex diene. Okay, what about this one? So first, we have our longest chain here, and we know that we also have a double bond and 2 side chains, or side chain of chlorine and iodine. So in terms of naming this, we are gonna have, and by the way, chloro, oops, chloro, oh man, comes first than iodo because of their alphabet here. In this case, we have to name it first. 1, 2, 3, 4. So we're gonna have 2 chloro and 3 iodo, but 2 ene. Now, in terms of naming alkyne, they actually all work similarly. So how you name alkenes and alkanes, you will integrate those knowledge and apply in naming alkyne. And remember that alkyne starts with the suffix of "-ine". Okay, say if we have this example here, we have a triple bonds in here, and it is so-called propyne. But what about if we have this example? Let's make it a little bit complex. In this case here, we have 2 triple bonds and a side chain of chlorine. So in terms of naming this, we are gonna have 1, 2, 3, 4. In that case, it's gonna be 1 chloro, but, and we're gonna have 1, 2 diene. So far, we have learned how to name H molecules of alkanes, alkenes, and alkynes. But they do actually have a specific equation to determine if whether they are really an alkane, alkene, or an alkyne. So consider this. For alkane, we have a formula of CnH2n plus 2. Sorry, that's supposed to be 2 right there. 2. For alkene, we have CnH2n. And for alkyne, we have CnH2n minus 2. And n, by the way, is an integer. They are an integer. In the next video, we're going to talk about benzene and some more structures in organic chemistry. We're going to take a look at the functional groups, and the cyclic structures. Oops, my bad. Cyclic structures of H molecules. Thank you.